Hello and welcome to lesson 4.6. Today we'll be talking about isosceles and equilateral triangles. We know what those are, but we're going to talk about some important characteristics of those triangles. In the past we've just identified what they are. Now we're going to use those properties to do some proofs and problem solving. So here's your new vocabulary. We talk in this lesson about what legs of an isosceles triangle are, what the vertex angle is, what the base angle is. But first, let's remember what an isosceles triangle is. Make sure this is written down in your notes. A triangle with at least two congruent sides is called isosceles. Now this next paragraph is very important. The two congruent sides of an isosceles triangle are called the legs, and the angle that is formed by those legs is called the vertex angle. The side of the triangle that is opposite the vertex then is called the base. So the side that is not congruent to the other two is called the base. The two angles that form the base, or formed by the base and the congruent sides, are called base angles. So let's just try and visualize this. In this triangle, these are your legs, these are the congruent sides. They form angle 1, so angle 1 is called the vertex angle. And then the base, along the bottom here, doesn't always have to be the bottom. I can very easily turn this upside down. Now it's the top, but it's still called the base. The base is the side that is opposite the vertex angle, and these two angles along the base, formed by the base and one of the two congruent legs, is called a base angle. Alright, we do have two theorems about isosceles triangles. The first is just the isosceles triangle theorem, and that says if two sides of a triangle are congruent, so basically if it is an isosceles triangle, then the angles opposite those legs are congruent. So in other words, the base angles are congruent. We could say in an isosceles triangle, base angles are congruent. And that's called the isosceles triangle theorem. Then we have the converse of that, which is also true. Remember, converse switches the hypothesis and conclusion. So if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. So if we have a triangle where two angles could be called congruent base angles, then we know it's isosceles because the opposite sides are congruent. Alright, let's take a look at this example. We are going to take a look at doing a proof of the isosceles triangle theorem. So let's look at what we are given. We are given a triangle where we have two sides that are congruent, and we want to prove that their opposite angles are congruent. Angle 1 is congruent to angle 2. We're going to do this by kind of dividing this triangle into two congruent triangles, and once these triangles are said to be congruent, then their corresponding parts are congruent. So that's what we want to show here. And there's actually a couple typos in the way this was written for you, so I want you to make sure that you are making the changes I tell you to make. But first, you'll notice we don't start with the given information. We actually don't get to that until the almost a little past halfway through the proof, because we're going to add an auxiliary line to set this triangle up the way we want it. We're going to add auxiliary line CX that goes through C perpendicular to AB, and that's because there's exactly one perpendicular that can be drawn from a point not on a line to that line. Okay, so I'm giving you that part. That's not something I'm going to expect you to have to write in every time. But then we're going to change the way this is worded. We're not going to talk about these two angles being congruent. We're not going to say that part of it. Here's what we want to focus on. We want to focus on the fact that these are right angles, and in fact then are right triangles. Okay, we want to say angle AXC and angle BXC are right angles. And that's just definition of perpendicular lines. Okay? So we have right angles there. Okay, in step 3 is going to move on into talking about how these triangles can be congruent. Now, because these are right angles, we're going to just understand that they are right triangles. I could write in another statement and reason saying that these are right triangles, but that is just going to be implied from the way it's drawn. We don't have to specifically state that. Now what we want to focus on is the fact that these two triangles share a side XC, so even before I state the given information, I can go ahead and say that XC is congruent to itself by the reflexive property of congruence. Now I can go ahead and state that given, and I'll show you why I decided to do that this way. AC is congruent to BC because that's given. Now let's look at what we've shown. We have two sides of these right triangles being congruent, XC, and then AC and BC. These are the hypotenuses of the two triangles, and XC is a leg of both triangles. So we can say that the triangles are congruent by hypotenuse leg. Since the triangles are congruent by hypotenuse leg, these corresponding parts, A and B, must be congruent. Those are angles 1 and 2. So we can say angle 1 is congruent to angle 2 by CPCTC. All right, we're going to skip over the next part of your notes, which is proving the isosceles triangle converse. We're going to look at that in class again. It works out very similarly to this, but we do change back to a couple of these things. And so we'll look at that in class. So you can go ahead and skip that part and move on to the very next set of examples. All right, let's take a look here. I've kind of written most of this out for you. I just want to kind of walk you through it so you can understand these things. So if we're looking at this diagram, I want you to be able to name two unmarked congruent angles from the given information. So if I'm looking for unmarked congruent angles, I'm going to look at where I have opposite sides marked congruent. And if I look at AB and AC, those sides are congruent angles. So since angle ACB here is opposite angle AB, or sorry, side AB, my bad, and angle B here is opposite side AC. Since these sides are congruent, these angles are congruent. So that's how I can get that last statement there. Okay, but then part B asks you to name two unmarked congruent segments. Well, we are given congruent angles C and D here, and those are opposite these sides. Since D is opposite AC, that angle will be congruent to, or sorry, that side will be congruent to the side opposite from angle C, which is AD. So I can say AD and AC are congruent. All right, let's talk about equilateral triangles then. We need to remember what equilateral triangles are. They're triangles with exactly 3 congruent sides. Equiangular triangles are triangles with exactly 3 congruent angles. Please notice that equilateral refers to sides. Equiangular refers to angles. So let's talk about, again, we've seen this in previous lessons, but corollaries are statements that can be easily proven using a theorem, and so we call those corollaries of that theorem. And so we have corollaries of our isosceles triangle theorems here, and that first one is the equilateral triangle. It says this: if a triangle is equilateral, it is also equiangular, and the converse, and so we say that is if and only if. A triangle is equilateral if and only if it is equiangular. That way, if you know it's equilateral, you also know it's equiangular, and vice versa. And we've talked about that before already. Then we have another corollary that explains that the measure of each angle of an equilateral triangle must be 60 degrees then. So if you know it's equilateral, you know all 3 angle measures are 60 degrees. So let's write this conclusion. If it is an equilateral triangle, then it is also equiangular. If it is equiangular, then it is also equilateral. These two statements are converses of each other. Because both of the statements are true, we call this statement biconditional. So let's try and do these problems. Let's take a look at example 3a. We are given these two sides that are congruent, and we want to find the value of each variable. And so I know it's kind of tough to see. We say this side is 3 inches. The congruent side must also be 3 inches. I'm going to go ahead and mark that. And then this other side is 4y minus 5 inches. Now I don't have a way of relating those yet, but I will in just a minute. So if I have each of these is 2x degrees, you'll notice if I call this an isosceles triangle, because I have congruent sides here, the base angles have to be congruent, so this side has to be 2x degrees also. So what we get is that all 3 angles are 2x degrees. That means it's equiangular. because it's equiangular, it's also equilateral. So 4y minus 5 does in fact equal 3 inches. So there's two equations we can come up with. One is to find x, one is to find y. I want you to try and come up with those equations, write them out, and then when you're ready, you can unpause the video and keep watching to see if you got the equations right. Alright, pause the video if you need more time, but this is what we should have gotten. Alright, to find x, remember all three add up to 180, but also remember this is an equiangular and equilateral triangle, so all three angles must equal 60. So we could just say 2x equals 60 degrees. Divide by 2, and then the value of x is 30. And then we have this equation that all three sides are the same length, so 4y minus 5 does have to equal 3. So we just add 5 to both sides, divide by 4 on both sides, and y is 2. Alright, why don't you try and do part B, and then check your answer when you are ready to go, push play. Okay, again, you need to pause the video if you need more time, but this is what we should get. Notice that this is isosceles, and so these base angles must be the same. And then remember, all three angles add up to 180. I don't want to say 6x plus 8 equals 60. This is not equilateral because this angle measure is 80. And so this is just isosceles. These angles will be less than 60 apiece because this is greater than 60. So we add these two together, or double that, 2 times 6x plus 8, and then add it to 80 to get 180. Or you might have taken the 80 away from 180 first and just set this 2 times 6x plus 8 all equal to 100, which means 12x plus 16 equals 100, and 12x equals 84 when you subtract 16 from both sides, and dividing by 12 gives you x is 7. For the y's, these are the legs of the isosceles triangle, so they are congruent. Therefore, 4y minus 2 equals 2y plus 2. When you solve that, you should get y is 2. Alright, again, I want you guys to try and work on finding the values of x and y in examples 3c and 3d. And then we will move right on forward. So pause the video to give yourself time to solve these. These take a little bit less time than each of the ones did before it. So solve those and get ready to move on. Alright, again, pause the video so you have enough time. Otherwise, these are the answers you should get. In example 3c, this is an equilateral triangle. Because it's equilateral, we also know it is equiangular. So 2x plus 32 has to equal 60. And so we solve and get x is 14. And then on 3D, it's equiangular, so we also know it's equilateral. So these sides must be congruent since all three are. And so you say 5y minus 6 equals 4y plus 12. Solve that, and y is 18. Alright, if you have any questions about these, make sure you make a note of it to yourself, and then we can talk about them in class. Otherwise, we're ready to kind of finish up the notes on lesson 4.6 with this proof. Now, all I really want you to do is to plan this proof out, and we will work on writing the proof in class, but we want to kind of plan it out, and I'm going to give you some guidelines, but then kind of let you write out a plan for this. So here's what we want to look at. We are given this information. I'm going to underline the given and what you're supposed to prove. This is the given information. It's the hypothesis. We want to prove the conclusion. Okay? So we're given that ACB is congruent to ABC. We want to prove that these exterior angles are congruent. And so we're going to do that. There's several different ways we could do that, but remember a couple things here. What we have are a linear pair of angles here and here. Remember, they're supplementary then by the linear pair theorem. So if I can say that the measure of ACB and the measure of ACX adds up to 180, and ABC and ABY also add up to 180, but since these are congruent, I can subtract that same thing from both sides and get that these are equal to the same thing, therefore they're congruent by definition. So we really don't have to focus as much on the isosceles triangle part of this as you might think. So what I would recommend for your plan is to write out some kind of plan that uses linear pairs to say the angles are supplementary, and then solve those equations so that the measure of XCA or AXC equals the measure of ABY, and then they're congruent by definition. So once you write that plan out, and we'll check those results in class.